Hi all. Now we are going to explore the fascinating topic of forces and how they influence the world around us. Okay, so every moment we observe from a falling apple to a moving vehicle, it is caused by forces, right? So a force is simply a push or a pull acting on an object. So what is force? It is simply a push or pull acting on an object, right? So forces can change an object's motion, speed, direction or shape. Okay, so in this lesson we will focus on gravity, weight and Hooke's law. So what is gravity? Any idea? Okay. So basically gravity is the force that pulls object towards earth, right? And the weight is the force produced by gravity by acting on an object's mass. So Hooke's law helps us understand how springs stretch when forces are applied. So by the end of this lesson, you will understand how invisible forces can be measured and predicted using mathematics. All right, so let's get started. So let's start with the important effects of force on objects. All right. So for the first, we have a point that it will initiate motion, right? A force can initiate motion. For example, a shopping cart remains stationary until someone pushes it, right? And what is second thing? A force can alter speed. A force applied in the direction of motion causes acceleration, right? While force in the opposite direction causes deceleration. So if an object is moving in this direction, okay, if an object is moving in this direction, if we apply a force from here, it will move more speedily, right? There will be an acceleration. At the same time, if we are pushing from the opposite side, it will have a deceleration. So the speed will be reduced. Okay. Third, a force can change direction, right? So that is what we meant by shift of direction. Okay. A football changes its path when kicked, right? And a satellite changes direction due to gravitational force. And finally, the fourth one is forces can deform object. Okay, right. So compressing a spring or squeezing a sponge, it will change the shape, right? So that is deform physical shape. So can you notice the weightlifter here? We have an image, right? So multiple forces acting simultaneously here. What are the forces? You can see push, pull, right? So gravity pulls downward while the athlete exerts upward force, right? So the gravity is trying to pull them downward, but the athlete is exerting an upward force. All right. So this demonstrates the force act on, we can say that the forces will often act together, right, rather than individually. Got it. Now let's see the contact forces versus non-contact forces. So forces can be classified into two major categories that are contact forces and a non-contact force. Contact force require physical interaction between objects. For example, it includes pushing, friction, and tension. Okay, so what is contact forces? It requires physical interaction, either pushes or pulls. And there will be some sort of friction, right? So friction act between the surfaces and oppose the motion. That is friction. And what about tension? Tension acts through ropes, cables, or strings when they are pulled tight. That is tension. And now let's check the non-contact forces. Non-contact forces act without physical contact. That is a difference, right? Without physical contact, right? So these include gravitational, magnetic, and electrostatic forces. Okay. So gravity attracts objects with a mass. Magnetic forces act between magnets or magnetic material. So electrostatic forces occur between electrically charged objects. Okay. So you have to understand these things. Okay. This will help us to distinguish between uh, identifying the forces or source of forces. Okay. In different situations. So this is gravitational, magnetic, and electrostatic force. So now let's check for weight. So what is weight? What do you mean by weight? So when you check on a weighing machine, you can identify your weight, right? Whether it is 60 kg, 50 kg, 70, 75, 90, whatever it is. So what do you mean by this weight? Basically, weight is a force caused by gravity acting on an object. So, for example, if a human being, okay, if a person weighs around 65 kg, which means that the gravitational force, the gravity is exerting 65 kg force on this person's mass. Okay, okay. So that is why whenever you go to moon, your weight will be different. To any other planets, your weight will vary, right? So in Earth, it will be based on gravitational force. Okay. So every object near Earth experiences a gravitational attraction towards the center of the planet. This attraction produces a downward force called a weight. Weight always act vertically downward, regardless of an object's shape or position. So the weight will always act vertically downwards. Okay. For example, a box resting on the ground. You can see the box resting on the ground, right? It experiences a downward gravitational force. Okay. The ground provides an upward support force to balance it. Okay. So without gravity, objects would not have weight. Therefore, weight depends entirely on the presence of a strength of gravitational field. So you might have noticed that the astronauts, no, when they move to the space after the gravitational forces level or the distance, they can simply float, right? But in on Earth, it won't be possible because of the presence of gravitational field. And outside the field, you can just float on the air. Okay, float in the air and all. Okay. So weight is a force of gravity. It will act vertically downward. Okay. So what is mass and weight? So we have mentioned two terms, right? One we mentioned as mass and another one is weight. Mass and weight are often confused, right? But they are not the same. Okay, so even though they sound same, they are not actually the same. Okay, so mass measures the amount of matter in an object. Okay, so that is the amount of matter in an object. And what is weight? It is the force due to gravity, right? So mass is measured in kilograms and remains constant everywhere. So whether you go to moon or Pluton, and any other places, okay, whether it is Saturn, Neptune, wherever you go, your weight will be, sorry, your mass will be the same. But what about weight? Weight is the gravitational force acting on the mass, right? So it is measured in newtons and varies depending on gravity. And mass is a scalar quantity, okay. But weight is a vector quantity because it has both magnitude and a direction. So consider a person on Earth and Moon. Okay, their mass remains exactly the same because the amount of matter in their body does not change. However, their weight decreases on Moon because lunar gravity is much weaker than Earth's gravity. Okay, that is why their weight will be decreasing. Clear? Now let's check the Earth's oblate shape. Okay, so we know that Earth is not a complete sphere or circular shape, right? Earth is not a perfect sphere. It is slightly flattened at the poles and the bulges at the equator. You can see here that, right? As a result, people at the poles are slightly closer to Earth's center than people at equator. So this distance is shorter, right? Compared to this distance. Okay. So because gravitational force decreases with the distance, gravity is slightly stronger at poles and slightly weaker at the equator. This means a person would weigh a little more at the poles and a little less at the equator. Okay, even though their mass remains unchanged. Although the difference is small, it demonstrates that weight depends on gravitational strength. That is the point. So when you weigh your weight at an equator region and you weigh it on at poles and all, there will be some variations in your weight, even though the mass is same. Okay. Now let's see the Newton's translation of mass into force. Okay. So weight can be calculated using this equation. Weight equal to mass multiplied by gravitational field strength. That is 9.8. So weight is equal to mass into 9.8. So on Earth, the gravitational field strength is approximately 9.8 newtons per kilogram. Therefore, weight will be is equal to mass into 9.8. A 1 kilogram object weighs approximately 9.8 newtons. Okay. And what about a 2 kilogram object? It will weigh approximately 19.6 newtons, often rounded to 20 newtons. So the unit of force is the Newton, named after the scientist Isaac Newton, right? Whose work laid the foundation for classical mechanics. Okay. Now let's see how to measure invisible forces with the mechanical acceleration. Because forces cannot be seen directly, we often measure their effects. Can you see a force? No, but we can feel it, right? So, one common instrument is a spring balance. When an object is attached to the hook, its weight pulls downward, right? So, this force stretches the spring. So, when you put a weight on the edge or this end on this hook, it will move downwards, right? So the spring's extension moves an indicator along the calibrated scale. So you can see the marked scale here, and we will measure the distance. Okay, the distance of movement of the spring. Okay, providing a numerical measurement of force. So the greater the force applied, the greater will be the extension of the spring. So this simple principle allows us to convert an invisible force into a visible and measurable quantity. That is why we are using it. So we have a readout here that indicate moves along the scale, right? Then mechanism, internal spring stretches in response to the force. And the load, weight pulls downward and the hook object is attached. These are the parts. So greater the weight, greater the stretch. Now let's observe how a spring responds to increasing loads. Okay. So initially the spring is attached and remains at its natural weight, right? It is unstretched. And when one slotted mass is added, so first we add one mass. Okay, the spring extend approximately 20 millimeter. Okay, so the distance is 20, the movement is 20 millimeter. When three slotted mass are added, the extension increases about 60 millimeter. See, so notice that the increasing force result in greater extension. So this relationship suggests that extension and force may be proportional, a concept that leads directly to Hooke's law. Okay, so as stretching force, that is the weight or mass, the weight of masses increases, the spring stretches further, yielding a larger extension. Okay, so now let's see the Hooke's law. Hooke's law describes how elastic materials behave when forces are applied, right? So the law is expressed mathematically as F is equal to Kx. Okay, F is equal to Kx, where F is the force applied, it is measured in Newton. X is the extension that is measured in meters, and K is the spring constant. Okay, clear? So this equation states that extension of a spring is directly proportional to the force applied, provided the elastic limit is not exceeded. The spring constant represents the stiffness of the spring. So Robert Hooke discovered this principle over 350 years ago and it remains one of the most important concepts in mechanics. Okay. So the spring constant represented by K tells us how stiff a spring is. So a large spring constant means the spring is stiff. It requires more force to produce given a given extension. A small spring constant means the spring is soft, less force is needed to stretch it. So we have different type of springs, right? With a large K and a small k. So you can see both diagrams here, right? So in both we provided the same force. Okay, 10 Newton was given and you can see the change. For a spring with a larger K, the moment is very small. But a spring with a small K, the moment is comparatively large. Right? So the stiff spring stretches only slightly while the soft spring stretches much more. Therefore, the spring constant provides a quantitative measure of resistance to deformation. Okay. Now let's see the graph. Okay. When force is plotted against extension, Hooke's law produces a straight line graph passing through the origin. Okay. Straight line graph passing through the origin. So the straight line indicates the force. So the straight line is the force. Okay. And extensions are directly proportional. The gradient of the graph is calculated using gradient is equal to change in force divided by change in extension. Change in force divided by change in extension. Okay, clear? So this gradient is equal to the spring constant K. So a steeper graph represents a stiffer spring because a large force is required for each unit of extension. And graphical analysis therefore provides an effective method of determining spring stiffness experimentally. Clear? So Hooke's law is only valid up to a certain point called the elastic limit. The spring will have an elasticity, right? So it is limited to the elastic limit. At the elastic limit, the spring can still return to its original length when the force is removed. Beyond this point, the graph begins to curve. So additional force produces disproportionately large extensions, right? And the spring no longer behaves according to Hooke's law. So if the force continues to increase, permanent deformations may occur. So the spring become permanently stretched and cannot return to its original shape. So this region is sometimes called the plastic region. So that is called as the plastic region. Okay. That is the permanent deformation region. Okay. This is how the graph will look like at that point. Now let's calculate force and extension in practically. Okay, let's do a practice. So let's apply Hooke's law in a numerical example. So a spring is stretched by 10 millimeter. Okay, it's stretched by 10 millimeter. That is 0.01 meter by a force of 2 Newton. Okay. So what we have to do first? First we have to find the K. So what is K? K is equal to F by X. So here we have K, right? K is given, that is 2 Newton. Okay. And we also have the stretch X, right? So by dividing it, you will get 200 Newton per meter, right? So we got the K. Now you can substitute, right? We can rearrange the equation, right? Kx will be equal to F. So we have to find the weight for the new extension, that will be 16 Newton. Okay. Did you get the point? So now let's summarize the entire lesson. So gravity is a universal non-contact force that pulls object towards Earth. And gravity creates weight, which is the downward force acting on mass. Weight can act on springs and other elastic systems. The systems stretch in response to force and their behavior can be described using Hooke's law. Hooke's law provides mathematical relationship between force and extension, allowing us to predict how elastic object will behave. Through this chain of ideas, physics transform invisible forces into measurable and predictable quantities. So this ability to model nature mathematically is one of the greatest strengths of physics. I hope it is clear for you. Thanks for watching.